Solve for p, q, r and s, where p, q, r and s are prime numbers, and satisfy 1 minus 1 over p, minus 1 over q, minus 1 over r, minus 1 over s, equals 1 over p, q, r, s, and p is less than q, which is less than r, which is less than s. We can see that, when p, q, r and s get larger, the value of 1 minus 1 over p, minus 1 over q, minus 1 over r, minus 1 over s increases and approaches 1. However, 1 over p, q, r, s becomes smaller and approaches 0. So, to satisfy the equation, p, q, r and s cannot all be large prime numbers. Consequently, to solve this Diophantine equation, we should start by trying small prime numbers. We can prove that p equals 2. If p is greater than or equal to 3, then the smallest possible values are p equals 3, q equals 5, r equals 7, and s equals 11. Then, the left-hand side of the original equation equals 1 minus 1 over 3, minus 1 over 5, minus 1 over 7, minus 1 over 11, which is equal to 1 minus 886 over 1155, which is equal to 269 over 1155. The right-hand side of the original equation equals 1 over 3 times 5 times 7 times 11, which is equal to 1 over 1155. Clearly, the left-hand side of the equation is larger than the right-hand side. As mentioned earlier, when p, q, r and s get larger, the left-hand side approaches 1, and the right-hand side approaches 0. When p, q, r and s take larger values than 3, 5, 7, and 11, respectively, the left-hand side is greater than 269 over 1155, and the right-hand side is less than 1 over 1155. Therefore, the left-hand side is always larger than the right-hand side, when p is greater than or equal to 3. This implies that p cannot be greater than or equal to 3. So, p must equal 2. Substitute p equals 2 into the original equation. We have 1 minus a half, minus 1 over q, minus 1 over r, minus 1 over s, equals 1 over 2 qrs. 1 minus a half equals a half. Multiply the equation by 2, we have 1 minus 2 over q, minus 2 over r, minus 2 over s, equals 1 over qrs. And we label this as equation 1. Similarly, we can prove that q equals 3. If q is greater than or equal to 5, then the smallest possible values are q equals 5, r equals 7, and s equals 11. Then, the left-hand side of equation 1 equals 1 minus 2 over 5, minus 2 over 7, minus 2 over 11, which is equal to 1 minus 334 over 385, which is equal to 51 over 385. The right-hand side of the original equation equals 1 over 5 times 7 times 11, which is equal to 1 over 385. Clearly, the left-hand side of the equation is larger than the right-hand side. When q, r and s get larger, the left-hand side approaches 1, and the right-hand side approaches 0. When q, r and s take larger values than 5, 7, and 11, respectively, the left-hand side is greater than 51 over 385, and the right-hand side is less than 1 over 385. Therefore, the left-hand side is always larger than the right-hand side, when q is greater than or equal to 5. This implies that q cannot be greater than or equal to 5. So, q must equal 3. Substitute q equals 3 into equation 1, we have 1 minus 2/3, minus 2 over r, minus 2 over s, equals 1 over 3 rs. 1 minus 2/3 equals 1/3. Multiply the equation by 3, we have rs minus 6s minus 6r equals 1. Rs minus 6s can be factored as s times r minus 6. Now, we add 36 on both sides of the equation. Negative 6r plus 36 can be factored as negative 6 times r minus 6. 1 plus 36 equals 37. Now, the two terms on the left-hand side of the equation have a common factor r minus 6, so they can be factored as r minus 6 times s minus 6. 37 is a prime number. The factors of 37 are 1 and 37. As r is less than s, so r minus 6 equals 1, and s minus 6 equals 37. So, r equals 1 plus 6, which is 7. And s equals 37 plus 6, which is 43. Therefore, PQRS equal 23743. Now, verify whether it is a solution of the original equation. When PQRS equal 23743, the left-hand side of the original equation is equal to 1 minus a half, minus a third, minus 1 over 7, minus 1 over 43, which is equal to 1 minus 1805 over 1806, which is equal to 1 over 1806. The right-hand side of the original equation is equal to 1 over 2 times 3, times 7, times 43, which is equal to 1 over 1806. Therefore, PQRS equal 23743 is the only solution of the original equation.